We defined acceleration as the rate of change of velocity the other day. If it's the rate of change of velocity, then it means it's going to be delta v over delta t. But although that's the main equation that we use for acceleration, and it is really just the definition of acceleration, there are 4 more equations that we're allowed to use whenever we have a problem involving acceleration as well. Those other 4 equations, in no particular order, are d is equal to vit plus 1/2 at squared. What does vi stand for there? What does vi stand for there? You guys know this, right? What's vi stand for? Spencer, what's vi stand for there? Good, it's initial velocity. Let's write down another one. D is equal to vft minus 1/2 at squared. What does vf stand for there? Nothing? Good, final velocity. What about this one? Vf squared is equal to vi squared plus 2ad. What does vi stand for there? Right? Good, it's initial speed, not velocity. It doesn't have the vector sign over it. So when we solve for vi there, it would be speed, not velocity, no direction with it. Vf would be the final speed, not the final velocity. Finally, we have that other equation, d is equal to vi plus vf over 2, initial velocity, final velocity, times t. All 5 of these equations are what I call group B equations. That means we are allowed to use them whenever the object is experiencing an acceleration, whenever it's speeding up or slowing down. Now, we also have another equation that we learned the very first day of class. V is equal to delta V over delta T. This is valid when we have constant velocity, not when the object is accelerating. This is our group A equation. What I want you to do every time you see a problem is look at it and identify whether it's accelerating or not. If it is, use group B equations. If it isn't, use group A. Okay, if it is, and you're not sure which group B equation to use, pick one. Worst case scenario is you find you're not able to use it, okay, try again. Okay, can't use that one, try again. Most you're gonna have to do is try 5 times because there's only 5 equations. One of them has to work. All right, we had a couple questions for homework last night on this stuff. It was on page 51. Any issues, please, with the questions on page 51? Number 1, okay. Anybody else for number 2? Okay, we'll do both of them here. Number 1 says, if the arresting device on an aircraft carrier stops the plane at 150 meters, an acceleration of -15, find the time that it takes the plane to stop. Do you know what the arresting device on an aircraft carrier is? No, not parachutes. Yeah, they have a cable across the runway of the aircraft carrier, across the deck of the aircraft carrier. And when a plane comes in, there's a little hook on the bottom of that plane. When a plane comes in to land, let's say this is the aircraft carrier here. And you probably don't want to be on that aircraft carrier because it doesn't look like it's in very good shape, but the plane comes in to land here. Looks more like a jetliner coming in to land. Probably don't want to land like a 737 jet on top of one of these things. Fighter plane, yes. 737, no. But you get the idea. On the bottom of this thing, there's a little hook. When this plane comes in to land, you would think that this plane would slow down, right? Because this plane doesn't have very much space to land. It's a very, very short distance over the deck of this aircraft carrier that it has to land. But when it's coming in to land, it actually doesn't slow down. The plane comes in and speeds up. They give it all they got. Why would they do that? They're trying to land. They give it all they got. If they miss, they don't want to crash. Here's the thing. If they miss that deck, or they come down right here instead of right here, right? Come down right here instead of right here, they don't have enough deck to land. So they want to take off again. That's why they speed up. As they're coming down here, they speed up. But if they're speeding up, then their brakes aren't good enough to stop them. So what do? They got this little hook right here with this cable that runs across from one side of the deck to the other. And now this hook the cable grabs the hook and it stops the airplane. Literally, the cable stops the airplane. Okay? It's like you're running by the fence, the outfield fence on a baseball park, and you catch your shirt on it, and what happens? It stops you, right? Okay, that's exactly what happens there. Now, if they miss it, and if the airplane overshoots that cable, what happens? He just keeps going, right? He just takes off again and keeps going because he's going fast enough to do that. That make sense? Anyways, stops this plane in this question at 150 meters with an acceleration of negative 15. Clearly, it's a Group B question, a Group B problem where we have an acceleration, slowing down. Okay, let's write down our givens and then see which of those 5 Group B equations we have that will allow us to solve this question. Something is 150 meters. Tell me what that is, please. Tell me what that 150 is. Yeah, good. It's the displacement. And we're going to say that it's moving forward. Therefore, the displacement will be forward. It's a positive value. The acceleration, it says, is negative 15. What does that mean? Negative 15. Why the negative there? Yeah. Good. It's slowing down. You can also think of it as an acceleration backwards. Okay, if you slow down in the forward direction, that's identical to an acceleration in the backward direction. Right, William? We want to find the time that it takes the plane to stop. We're going to say that VF is equal to 0 because it's stopping, and we want to find delta T here. Which equation of those 5 do you want to try here? Let's name them. Let's call them 1, 2, 3, 4, and 5. Which of the 5 do you want to try there? I know what I want to try, but I don't want to tell you. Who got this question? Who got it right? Okay, what'd you try? Cade, what'd you try? Yep. D is equal to VFT minus 1/2 AT squared. That's exactly what I was going to try. Yeah, I don't know for sure when I say this is what I'm going to try. I don't know for sure if it's going to work, but it's worth trying, okay? And we know it's a valid equation, so there's no danger in trying it. D is equal to VFT minus 1/2 AT squared. Looking for T. Okay, I know what D is, I know what VF is, I know what A is, so I should be good to go. It's only one unknown. Let's rearrange this. Wow, seems kind of ugly to rearrange though. The first thing that I want you to notice there though is this, before we even rearrange it. This equation becomes D is equal to negative 1/2 AT squared. Where did the VFT go? How did I just arbitrarily drop the VFT? Why is it gone? Yeah. If VF is equal to 0, 0 times whatever T is, whatever it is equal to 0. So that term just disappears. I want to solve for T here now? Let's take the half over by dividing. Right, the half is multiplied by A. Let's take it over by dividing. Actually, let's take negative a half over because it was negative a half AT squared. It's multiplied by A times T squared. Let's take it over by dividing. Now we got to take the A over by dividing because it's multiplied by T squared as well. It becomes D over negative 1/2 of A. And now I got to get rid of the squared. How do I do that? Square root it. So it becomes the square root of D over negative 1/2 A equals T. My displacement was 150 meters here. My acceleration was negative 15. So I'm going to say negative 1/2 of negative 15. Then we're going to square root that. A half of 15 is 7.5. Negative a half of negative 15 is still 7.5. 150 divided by 7.5 is 20. The square root of 20 is going to be 4.5-ish. What is it? Oh, 4.5. They have the answer in front of me, right? I don't think it's exactly 4.5, but rounded to 2 digits it would be. Does that make sense? How's the rearranging of that? How's going from this step to this step? Is that okay? Remember, if you want to get rid of something that's multiplied, then divide. If you want to get rid of something that's added, then subtract, and so on. Yeah. If VF wasn't 0, that's a good question. If VF wasn't 0 in this question, you couldn't use this equation because t would be in two places there with a t and a t squared. Now, there is a mathematical technique that you can use to solve for that, but most of you have probably never heard of it before. It's called the quadratic equation. Okay? Have you guys ever heard of the quadratic equation? Negative b plus or minus square root of b squared minus 4ac over 2a. That would allow you to solve for t there, but because not all of you have seen that in math class, I wouldn't give you a question where you'd have to do that. Okay, good. Okay, let's take a look at number 2 here. This one says the 1968 Corvette took 6.2 seconds to accelerate to 160 kilometers per hour north. It's about 100 miles per hour. It's pretty good for 1968. That's 45 years ago. This car's going from 0 to 100 miles per hour in 6 seconds. Pretty good. We got a time here of 6.2 seconds. What's the 160? Let's make north positive. Everything's positive here. What's the 160? That's a velocity, right? But is it VI, VF? What is it? What is it? Yep. It's VF. It's the final velocity. VI would be what? 0. And we're looking for, we have the displacement. We're looking for the acceleration here. Let's convert this to meters per second. That's 160,000 meters divided by 3,600 seconds. Okay, what do we get there? 160,000 divided by 3,600 seconds. Get 44.444. All right, what do you want to do here? You want to find A, you got T, you got VI, you got VF. Which one do you want to try here? Go ahead. Let's try the third one, okay. D is equal to VFT minus 1/2 AT squared. I don't know if that's going to work. It's okay. We know it's a valid equation because it's a group B equation. If it doesn't work, then we'll try another one, right? It's worth trying here. D is equal to VFT minus 1/2 of AT squared. We want to find A here. Now, this is a bit tricky to rearrange because we can't get rid of VF here. We can't get rid of that term. We want to solve for A. Here's what we're going to do. We're going to take the entire term VFT over first. VFT is not multiplied by A. It's not divided by A. It's a positive number that's added to A. Now, you see a negative in there, and you think, oh, it's subtracted. No, it's not. This isn't subtracted from A. A is subtracted from it. Let's take this over by subtracting. It's the opposite of adding. So let's say D minus VF times T. We're allowed to take both of those things over at once because they're multiplied together. They're one term. V minus VFT equals negative 1/2 of AT squared. Is that step okay? If it's not, please say something now, if that doesn't make sense to you. Now we got to get rid of the half, or the negative 1/2. Let's take it over by dividing since it's multiplied by A. Let's say D minus VFT. Let's divide that entire thing by negative 1/2. Since it was multiplied by the A. Now we got to get rid of the T squared. It's also multiplied by A, so how are we going to get rid of it? It's the opposite of multiply. Yeah, the opposite of multiply is? I thought you were ready to say something there. Okay. Or Ryan. Yeah, it's dividing. So let's say D minus VFT over negative. Sorry, that shouldn't have been negative 1/2 A. It should have been just negative 1/2. Divided by negative a half. We've just divided by t squared. So it should look something like this. D minus VF times T over negative a half times T squared. Let's plug our numbers in now. D, the displacement was, oh, wait a second. After all of that rearranging, I don't know what the displacement is. So what do I do? Oh, did they give me the displacement? Oh, sorry. Yeah. Yeah, sorry. Sorry. We do have the displacement. I just wrote it down wrong. Thank you. Which does allow me to do this now, okay? But if it didn't, what would I have done? If I went through that process and found that I couldn't get A because I didn't know what D was, what would I have done? I just would have tried something different, right? No harm done. It just would have taken a little bit of time out of my precious time out of my life that I'll never get back. But that's okay because it's like 30 seconds, right? It took me to do that. A is equal to 220 minus VF times T. That's 44.444 times a time of 6.2 seconds. Divided by negative a half times 6.2 squared. Now this is even kind of ugly putting it into our calculator here. Let's do this as a group here. Let's say 220 minus, let's use some brackets here, 44.4444 times 6.2. Let's end those brackets. Let's press equals. Negative 55. Let's divide that by, we're going to use some brackets, negative 0.5 times 6.2 squared. End the brackets. You get 2.89. Is that the answer they give me? 2.9. 2.9 meters per second squared. Who got that? That's a tricky question. Anybody else use a different equation? A different way to do this? I'm curious, was there an easier way to do this? Liam, was there an easier way to do it? What did you do? Dustin? Yes. Yes, you could have. That would have been an easier way. Yes, dramatically easier way. A is equal to delta V over delta T. Did you do it that way, Dustin? Did you get the right answer? Yeah. Is it right to assume that the initial velocity? Good question. Oh, good question. Oh, John, that's a great question. That's why you had an issue with that equation, right? Delta V over delta T, because it doesn't say that VI is equal to 0. So A is equal to delta V over delta T. It's a valid equation, but if I put in the wrong value for VI, then it doesn't work, right? Okay, good point. Good point. What did you try? Okay, VF squared is equal to VI squared plus 2ED. What'd you use for VI, though? Okay, so there's your issue with that, too. Okay, you got to be careful with that. Again, a valid equation, but if you don't know what the value of VI is, you can't do that. Okay? Yeah, that's the thing, right? The assumption is it's from 0, right? But it doesn't actually say that. So what was the initial velocity? I'm not sure, but it might not have been quite as good as we thought it was, right? If the initial velocity was, say, 150. Okay. I want to do one example with you today, and honestly, that's all I want to do with you today is one example. We'll give you some time to work on a couple questions there, some check and reflect questions, maybe 2 examples. I may have lied, maybe 2 examples. Okay, a couple practice questions, some check and reflect questions, and that's it for the day. So it says a bullet accelerates through the length of a barrel of a gun 0.750 meters with a magnitude of 5.35 times 10 to the 5. What speed does the bullet exit the barrel? It's a group B problem. It doesn't say here that VI is equal to 0, but John, I think it's reasonable to assume that it does here, right? In a gun, How fast is the bullet moving before it's fired? 0. It doesn't have to tell us that. We know that, right? We know that the acceleration is 5.35 times 10 to the 5. We know that the displacement is 0.750 meters. And we want to find VF. We want to find out how fast it leaves the barrel of the gun at. What do you want to try? It's group B. Can't use V equals delta D over delta T, but I can use any one of the other ones that I want as long as the givens fit. Take a look at your data sheet here, okay? Top right-hand corner. All of them except for V equals D over T. Which one seems to fit? Okay, Dustin's suggesting that we use VF squared is equal to VI squared plus 2AD. Okay, that's a valid equation. Let's rearrange that to solve for VF. How do you get VF when it's squared? Square rooted, right? VF is equal to the square root of VI squared plus 2AD. Now I'm going to cross this off because VI is 0. 0 squared is 0. 2 times 5.35 times 10 to the 5 times the displacement of 0.750. I get 895 or 896. Anybody else get that? Anybody else get 896? We've done sample problems now with each of those 5 acceleration equations. Okay, we know how to deal with them. Write down your givens, see which one you think fits best. If you're wrong, don't worry about it. Try again. If you're wrong with that one, don't worry about it. Try again. Okay, worst that happens is you got to try 5 different equations to make it work. And although that takes a bit of time, eventually you'll get it right. As long as you don't make a mistake, John, like I did, and like a couple other people did, and say VI is equal to 0 when it doesn't say that it is, right? All right, let's have a look at these 2 questions. Here's what's homework for tonight. I'll tell you right now. Page 52, questions 1 and 2. And here's the rest of them. There's some more check and reflect questions on page 53 as well. Write these down and you can have the rest of the class to work on these, okay? On page 53, I'd like you to do question number 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 to 14. Got it? Everybody know what they're doing here? No, I don't think I'll do that. Check and reflect questions, page 53, number 1 to 14, plus these 2 questions. You've got almost 20 minutes to work on them in class here, so we should get a pretty good head start here, okay? Okay, let's get to work.